Okay, it's Tuesday, it's 1 o'clock. Welcome everybody to our HDF clinic. I apologize on our Google Work document where you can submit questions. I got the date wrong. I created the impression that there wouldn't be a webinar today. We had a little bit of a break last time because we had an internal here at the HDF Group meeting. And so we had to cancel, unfortunately, but we are back, and we are back for the foreseeable future. So welcome, everybody. And yeah, before I jump into it, lots of things to catch up on. Let me start by asking if there are any questions at this point. No? Okay. Then let's jump right in. It's a little bit of a catch-up today because, yeah, again, we had a lapse last week. I have not, what I promised, tried this parallel experiment. I'll follow up with that probably next week. Oops.
Gerd, we've lost sound. I don't think he can hear us when he loses it.
Is it back now? Okay,
yeah.
Sorry. My apologies. Yeah, it's Zoom. Maybe we have to look at other solutions in the future. Okay, we had our Hermes webinar, and just stay tuned. The recording will be available on YouTube. And we also have now a category, a Hermes category on the forum. So check that out because one of the things that we mentioned in that webinar was there would now be a monthly cadence of releases. And so there will be a December release, and we'll announce it in the forum in that category. The other big announcement was we just released HDF 5.1.13, and that might strike many of you as what's that odd release number, because we are in the tradition of even release numbers, 1.8, 1.10, 1.12, and so forth, and before that 6 and 4 and 2 and 0. And so there is a blog post that we put together about these experimental releases, and I put the link in here. I'm not going to go through it, but the gist of it is basically that from here on, there will be two types of releases: the usual maintenance releases that everybody is familiar with by now, and these experimental releases whose purpose is really to introduce the community to new features that we would like to see tested more thoroughly in the sense of use cases. So that's why I'm saying here, this connotation or this attribute of experimental is not a fig leaf or a way to say, well, these are shoddy releases, or the quality is not up to the level that we expect from ourselves and that you should expect from us. Experimental means, as far as the quality is concerned, no less tender loving care for these experimental releases than our maintenance releases, in the sense that they go through the same release process in terms of the daily testing and quality assurance and so forth. So experimental has nothing to do with the quality of the release. However, as some of in the past, I think we sometimes called them snapshot releases or something like that. There are breaking API changes typically in these experimental releases, breaking API changes in terms of API compatibility, and there might be file format extensions for the specific new features that are introduced perhaps with an experimental release. And that's where the experimental really comes from. Nothing to do with quality. It's really features where we would like to see, do they achieve what we hope they might achieve, what the community's reaction might be to them, and so forth. So for this particular 1.13 experimental release, the highlights are and again, you should go back to the release notes here. They're basically updates to the virtual object layer interface, to the DAOS plugin, the pass-through VFD, and the wall, not VFD, and the asynchronous wall. And there are a few VFD layer updates, in particular what we have spoken about in the past, that now VFDs are dynamically loadable as plugins, and I believe also the dynamically loadable version of the VFD that takes advantage of the NVIDIA's GPU Direct feature is included in this experimental release. Then we also mentioned that in the past there are some performance improvements related to sort of macro rework, and then here's an interesting one. Included is also this H5D walk tool, and what's linked here is the documentation of H5D walk, but I just copied a simple example from that documentation for you. What H5D walk lets you do is, first of all, it is a parallel tool. So if you look at this snippet here, I'm invoking this with MPI exec. So I'm spawning, in this case, 4 processes of H5D walk. And you can think about it as a harness that you can use to invoke HDF5 command line tools. So in this case, I'm invoking H5 dump. So it's -t, in this case, H5 dump. And then you can specify a file in which you will capture, or this tool will capture the output. And then there are options where you can specify a set of directories or files that you want this tool to visit. And so what H5D walk will do is basically look at your inventory, so to speak, the files that need to be processed, and then basically divide that list among multiple processes, and then do that processing in parallel and basically gather the results into a log file. So again, I recommend there are more use cases in the H5D walk documentation, but the idea is basically, yeah, it's a, call it a poor man's map reduce, or it's a simple parallel MPI based at that harness to invoke MPI tools to invoke sequential HDF5 command line tools. Okay, and last but not least, in the announcement department, you've probably seen, if not, make sure your calendars are up to date. The wall tutorial that was scheduled, I believe, for next week originally on how to create a basic terminal wall connector, that was moved to January the 14th. I think the time is still the same. I believe it's 11 Central to 1 o'clock. But yeah, note that that has moved to January next year. Makes a great New Year's resolution to attend that for my money, but you'll see. I'm going to pause here and ask: are there any questions?
No questions.
No. Okay. Good. We'll just press on. We have lots to catch up on from the forum, things that we didn't get to last time. Okay, there was a question about someone working with packed 12-bit integers, and they are fundamentally packed 12-bit integers. What that means is, somebody has a very good idea of the range in which integer values that they would like to represent vary, and they figured out that they really need only 12 bits rather than the closest sort of byte aligned integer length here would be obviously 16 bits. But they say, well, I'm not really using those 4 bits. Now, if you're extremely conscious of space usage and so forth, there are different options that you have. You can either pack them, meaning I'm trying to figure out here what the smallest multiple would be. So 24, then it would be 36 plus 12, 48, not quite. Another 12 would be 60. I don't know. So what you can try is you just take multiple of these 12-bit integers and then use the 4 bits cumulatively to squeeze in another 12-bit integer. So that's what's meant by packing. That would be one strategy. It would be a little fiddly, but it would be okay. But then, of course, you would have to keep track of metadata. You would represent this probably as an opaque type, which is just an uninterpreted byte sequence. But then you would have to maintain some metadata that would tell a recipient of that data how these otherwise uninterpreted bytes should be interpreted. Another one is through filtering. Through the filter pipeline, you can do some pre-processing. And there was a comment from one user who recommended this H5 Turbo PF. I forgot already what PF stood for. But this is basically an HDF5 filter front end for this allegedly fastest integer compression. And I think the person that asked that question was satisfied with that answer. And so that was a long time ago, maybe 2-3 weeks ago, but it was an interesting tidbit. So someone from the community helpfully sort of jumped in and pointed that out. Next up, there was a question. Yeah, a user was trying to work with a variable length data type and had a question about how to set the values. And unfortunately, in this case, unfortunately, on different counts, he or she was trying to do all that from Java. And as in so many cases, there are many different choices of, in this case, Java interfaces available. So for example, from us, the HDF group, there are 2 interfaces. There is the low-level interface, I believe, which is called HDF Java. Then there is sort of a slightly higher level interface that underlies the HDF View implementation, which I believe is called the Java object interface or something like that. Then Bernd Rinn in Switzerland, he has a Java interface, which I think it's maybe just called H5 Java or something like that. So there are many interfaces, and the unfortunate thing with these interfaces, with many of these interfaces, is they are in a way partial implementations of the API. So they typically don't support all the different imaginable data types. So, and that's understandable. The authors of these tools typically implemented them with a particular application or particular requirements in mind. And why would they spend extra time of making it more general and then potentially slower, make the implementation more complex and so forth. So unfortunately in this case, either nobody really felt the need for supporting variable length data apart from variable length strings, because I believe all of them support variable length string data types. However, if you would like polygons, for example, let's say you represent them as variable length integer sequences, then unfortunately that is not supported. And so for us, there are just some, there are certain languages where we at the community have not been very successful of creating an interface that everybody sort of can rally around and sort of bundle their efforts and then create something, such as in the case of H5Py, for example, that everybody is happy with, and then everybody who wants a change or an improvement chips into that. And so it's a sad story. the user was basically describing what he or she wanted to do, and that was conceptually correct. However, the implementation, if you look at the commentary in this, I looked at the code briefly, and yeah, I could see that the variable length sequence type was actually not supported for anything other than strings. And the only thing I could recommend was that in HDFQL, variable length data types are supported. And there are Java language bindings for HDFQL. There are Java language bindings, .NET, C, C++, Python, etc. So that might be an option. But then again, people have different constraints in their application development, and they might say, well, I don't want another library dependence in my development and so forth. And that's all perfectly understandable. But again, unfortunately, with respect to variable length data types in Java, it's kind of a sad affair at this point. Okay, I'm going to pause here just to see if there are any questions. No? Okay. Then I will just press on. Another interesting case, and I believe the two next questions are related or came from the same person, if I remember correctly, but this is now more than 2 weeks out. So yeah, there was a question about, yeah, large numbers of data sets and attributes and so forth. What is best in terms of layout? And of course, sometimes people use the term layout to mean something slightly different from what we mean when we say data set layout. So for us, data set layout means the storage layout of a data set, which can be null, compact, contiguous, chunked, or nowadays even virtual. This is what we mean traditionally by layout. But some people, when they say layout, what they also mean is how you structure your data, for example, in terms of groups and links and whatnot. How do you arrange your data set? And I believe this person meant actually both. They meant the layout of the data sets individually, but also the overall layout, because they were dealing with very large numbers of objects, and that's where the B trees come in. So the problem was that they were acquiring a lot of small data sets. By small, they meant less than 8 kilobytes and so forth. And yes, if you mean this as storage layout and look at it in isolation, definitely compact layout would be the thing to use. However, if you look beyond just the layout of an individual data set, and you remind yourself that you have potentially tens of thousands, hundreds of thousands, or millions of these, then making all these compact data sets may actually not give you very good performance. And then you have to look into situations where you might be able to stack, to combine some of these messages or data sets in larger multidimensional data sets. And of course, you have to think about what is your measure of performance? Is your measure of performance purely throughput for reading and writing, or is your measure of performance also, does it include, for example, the size of the file? And then, yeah, how will these messages be accessed? Do you write them only once and then the files are static and you keep only reading them? Then obviously read speed, read performance is very important, perhaps write not so much. But so these are all considerations. And then more specifically to the point of how you lay out, assuming that for some reason or another, you decided that you really don't want to further compact these individual data sets into stacks of things. now you start thinking about laying them out in groups with a certain depth of nesting. And then you might think about one or more of the parameters that allow you to control the balanced trees or B trees, or they're actually B plus trees, but that's a technical detail, that are used in the HDF file to store these objects. Now, just for those of you who sort of may not have sort of a perfect grasp on B trees, I copied in here whenever I try to remind myself of B trees, I put a link in here. There's this nice little tutorial or note from a CS course at the University of Washington, I believe. And so this answers pretty much all the questions, or the basic questions about B trees, where the B actually stands for balanced trees. And then if you are dealing with a B plus tree, that means that these leaf nodes are actually also arranged in lists, that you have a linked list so that you can easily traverse between these leaves. But the HDF5 library includes B plus trees, but for this discussion, the only thing that's important is that these are balanced trees, so that all leaf nodes have the same distance in terms of number of hops from the root. And another thing to keep in mind, as we said earlier with the layout discussion, there are B trees come up in HDF5 in at least two places. One is, as we just said, when we think about the group structure, and when people use the word layout, we prefer actually the term profile. We say the arrangement of data sets and so forth in groups and so forth, that's a profile. We don't call that layout because we think layout is sort of reserved for data sets for the storage layout. But anyway, so with these B trees, what happens basically is that when you have a group, you can think of a group as a collection of links. And then what characterizes a link is basically a source and a destination. The source implicitly, of course, is the group of which that link is an element of or a part of. And then the destination, which for argument's sake, let's just stick with what we call hard links, meaning the destination is going to be another object, another data set, another group, and so forth in the HDF5 file. And that link, of course, also has a name. Within the group, that name must be unique. So in a given group, you cannot have two links that are called foo. You can have foo1 and foo2, but you cannot have two links whose name is foo. And then the question is, well, how, let's think about thousands or tens of thousands of such links in the group. How are they actually stored? Well, they are stored in exactly such a B plus tree or B tree, where the names of the links are stored at the leaf level. Well, the names as strings are actually stored on what we call a heap, but the references to the heap, that's pretty much what makes up the leaves of these leaf nodes of that B tree. And you can control the number of names or references of names in a leaf node, the maximum number, through this call h5p setSymK. That is a function to manipulate a file creation property list. So this plist ID is a file creation property list. It's important to keep in mind, by manipulating this file creation property list, if you change the default configuration of these B trees, then this is file global. So if you decide that typically you will store, for argument's sake, 16 link names in a leaf of such a symbol B tree, so you set this parameter, the second parameter here to 16, then this will be applied for all groups in the file. So it's not that you can change that for one file or another. And then the second parameter here is the so-called half rank. The PowerPoint slide here refers to that as the integer part of m half, which means that the number of keys stored in a given node, internal node in this B tree, will have between integer part of m half and m children. And that's this previous parameter that's called here ik. So if you go to the documentation and look at the reference manual entry for H5P setSymK, you will read terminology like the half rank of the B tree and so forth. But since I gave you this, you shouldn't have difficulty translating that. And then, of course, as I said earlier, there are two types, at least two types of B trees. We also use B trees to store the chunk in, if you're dealing with chunk data sets, to store that chunk index. And in this case, again, unfortunately, this is again, although these are data set chunk indices, you might think, well, can I set this on a database by data, on a data set by data set level? And the answer is unfortunately no. When you change this property, it's got to be changed on a file creation property list, and which means that once you decide on, in this case, it's the half rank of this B tree, and for the chunk index, basically the leaves of this chunk index are the chunks of that data set that have values on them. And unfortunately, again, yeah, this cannot be set on a data set by data set level, as far as I know, and so is a file global thing. So this is one option to play with these. The documentation mentions what the default values for these different parameters are. I forgot already. It might be that for the number of symbols for these leaf nodes is 16. The maximum number of symbols is 16, and the half rank, I believe, is 8. But don't quote me on it. Go to the documentation and look at it. It's defined. And if you know something about the tree structure that you anticipate for your profile, then you can certainly optimize these parameters. But again, it requires a lot of knowledge. And if you change this down the road, it's something easy to forget about. And so it's a double-edged sword. The parameters are there to be manipulated and so forth, but you got to be careful here. I mean, you can't do anything wrong. It's just performance-wise, you may not help yourself by playing with these. Okay, other potential remedies to tackle or to deal with these large number of objects. There were file format improvements over time. So in the file format versions compatible with the 1.8 family of releases and higher, there were some additional layout options. I think we also implemented a version 2 B+ tree. So in the oldest generations of the file format, there is a certain first generation B+ tree implementation, and then there was a second B+ tree implementation. So that might be of benefit. And then again, as I said earlier, by just trying to combine several of these otherwise large numbers of small objects into larger objects, that might be of help. And then I have a correction, which was that I think 2 weeks or 3 weeks ago, I was sort of speculating about whether the HDF5 Swimmer VFD would be available as a plugin, and the answer is, at least for now, no. Dana, if you sort of pick up on this thread, Dana replied, one of the main developers behind the Swimmer VFD, and he said no. not for the first release, definitely not. Maybe in the future. So that's your answer. And I think we have almost out of time. One more, which was somebody asked about virtual data sets. And the question I quoted here, the main part of the question, or the most relevant part of the question, where the person asked whether they could take control over the error behavior when, just for your recollection, virtual data sets are basically, we talked about data set layouts, and one of the data set layouts, the storage layouts, is virtual, which means that you can define a data set that is like a metadata shell where the actual data set values are stored in other data sets elsewhere in the file, in the same file, or in other files. And this person was asking whether, if you, let's say, you access a certain element in a data set, it just so happens that the data set or the entire file that's backing that region of that virtual data set is not available, that the person wanted that some kind of error message be raised by the API. Unfortunately, that's not possible. What the API will actually do is it will just return the fill value. So if a file is missing, or a data set is missing, or a chunk of a data set is missing, the API will be rather forgiving and say, here's a fill value. So it's not going to create an error. So that's why I believe I replied to that. The way these VDS APIs are designed, that at the moment you have no control over changing the error behavior, which is also pretty tricky, because it's very difficult for the HDF5 library to, in a way, know the programmer's intentions. And what you can, however, do in the meantime is what I would call take a pedestrian approach, which is that you can certainly, when you have a virtual data set, you can inspect its metadata. You can find out which files are supposed to be present, from which values, from whose data sets values will be drawn to populate that virtual data set. And so before accessing, you can just test them. You can enumerate that metadata and test for the presence of these files. And if one of them is missing, then you can create that error behavior that you desire. But unfortunately, out of the box right now, to my knowledge, there is no mechanism to change that default error behavior, which is really just return fill values. No error, return fill values if something is missing. And that's it. We are out of time. Thanks very much for coming. And maybe next time we can do more tips and tricks, because we don't have to go through such a big backlog. Thanks for coming, and come back next week and enjoy.